Hey everyone, and welcome back to this channel. In this video we're going to be getting started with an MG996R servo motor. I'll first of all show you the different types of motors and which exactly we're going to be using. Then I'll explain to you the working concept behind the code that we're going to be flashing. We'll then make the hardware connections and flash the code. So let's jump right into it. Alright, so as you can see, I'm using MG996R from Tower Pro, and this one specifically has a silver colored top. You'll also be able to find MG996R with a gold colored top, and the difference between the two is the gold one has all metal gears inside, whereas this silver one has a few plastic gears inside of it. So just in terms of longevity and performance, I would recommend you use the gold colored one because it has all metal gears inside, whereas this silver one has some plastic gears. But for the purposes of demo, we're going to be using this silver colored one. So let's see the working principle behind the code. Before we make the hardware connections and flash the code to the servo motor, I'd like to show you the working concept behind the code which we're going to be uploading today. So for that, I'll move over to this screen. I'll open up this page. So this is Arduino getting started with MG996R, and you can see these are the connections that we're going to be doing in the hardware section. But for now, we want to move below, and these are all of the methods which are available in the code for us to write. For the purposes of this specific tutorial, I'm going to be using servo.write method. If we open this, you can see that on a continuous rotation servo, which is our servo motor in this case, this will set the speed of the servo with 0 being full speed in one direction, 180 being full speed in the other direction, and a value of near 90 being in no movement. So what this means, if we want to illustrate this using this graph, is that 90 degree, if we write 90 degree on our servo motor using this servo.write method, the motor will stall. It will stop at its place, it will not move. If we write, let's just say 110 degrees, right, it will start rotating in one direction but with a slow speed, because the speed is equivalent to the difference between these two. If we were to write, let's just say 133 degrees, in that case it will rotate in this direction but a little bit faster than this one, all the way up to 180 degrees. If we were to write 180 degrees to the servo motor, it will rotate in this direction but as fast as it possibly can. Now same concept applies to the other direction as well. So if we were to write 85 degrees, let's just say, to the servo motor, it will rotate in the opposite direction but with a relatively slow speed. And further, if we were to write, let's just say any amount, let's just say 41 degrees, it will rotate in this opposite direction but much faster, all the way up to 0 degrees, 0 degrees being the fastest. So for the hardware connections, I'm going to be using a basic Arduino UNO. You can use any other microcontroller you want to. The setup is quite basic. You just need a voltage, a ground, and a signal pin. So any microcontroller would do, but for this tutorial, I wanted to keep it quite basic. So I'm going to be using an Arduino UNO. Now on the servo motor, you can see that there's 3 wires coming out of it. There's a brown wire, a red one, and an orange one. Back in the Arduino getting started, you can see that the red one refers to the voltage one, and brown one in our case refers to the ground pin, and the orange one refers to the signal pin, which in our case I'm going to be using the 9 number pin on Arduino. So I've picked up a pair of similar colored jumper wires. I'll connect the orange color one with the orange wire of the servo motor, the red one with the red one of the servo motor, which is the voltage pin, and lastly the brown one with the brown wire coming from the servo motor, which is the ground pin. The servo motor also comes with these hooks which we can place on top of the servo motor. I'll grab this specific part and I'll attach it on top of the servo motor. Now for the other side of the jumper wires, the brown one is the ground signal, so I will put this in the ground of the Arduino UNO. The red one is anywhere from 4.8 volt to 7.2 volts, so I'm gonna put this in 5 volt of the Arduino UNO. And lastly, the orange one, which is the signal pin, I'm gonna put this in GPIO 9 of the Arduino UNO. For the software part, you can either use Arduino IDE or you can use VS Code with Platform IO. Now the code is pretty basic, so you can use any option, whichever one you prefer. In my case, I like to use Platform IO with VS Code, so we'll use that. I'll jump over to VS Code, and this little icon over here is the Platform IO, and if we click here, we can create a new project from here. In case you do not have Platform IO installed, you can head over to extensions, search for Platform IO IDE. This is the extension that you need to install. Once you install this, and you can close the VS Code after that and restart, you should be able to see this icon over here, and from here we can create a new project. So I'll create a new project, and let's just name it Servo MG996R, and we need to select a board from here. Now this depends upon which microcontroller you're using to control the servo motor. Whether you're using an ESP32, you can select the specific board from here. In our case, we're using an Arduino UNO, so I'll write Arduino UNO. We can see this option from here. I'll select this board and click on finish. It will take a couple of seconds and our project should be ready. So if I come over here to the source main.cpp, this is just a sample code. We do not need this. And in Platform IO, we can see the specifications for our environment. The board is UNO, framework is Arduino. So inside of the main.cpp, I have pasted this code. This below code is not the part, it was just Copilot giving suggestions. So this is the basic code that we're going to be testing. Now before testing this, we can see that this library is not found here. So we need to install this in the Platform IO in this specific project. So for that, we'll head over to Platform IO libraries. We'll search for the servo library, and this specific library we can see allows Arduino boards to control a variety of servo motors. So let's just install this one, add to project, and we'll need to see the name of our project. Here we have it, servo MG996R. I'll click here and click on add. Now this will add this library hopefully to our project, and we can see that the error is now gone, so the library has been included. So in this code, we're in the setup part, we're doing serial begin, and we're specifying the 9th GPIO pin of the Arduino, which we connected our orange jumper wire with. And then it's a simple serial println, MG996R is ready for testing, right? Now after that, in the loop, I'm giving it a delay of 3 seconds before starting, and then I'm writing 90. Now if we remember from the earlier part, this 90 is not supposed to do anything. The servo will just stay at its part. So let's just flash this code and see the results we get. In order to flash this code, first of all, we'll click on this tick to verify there are no errors in this code. Once this is done, we'll provide power source to Arduino UNO. In this case, I'm just gonna connect this with my MacBook. Once the connection is done, we want to make sure the correct port is connected, and after that I'll use this button to flash or upload the code to the microcontroller. Alright, so the code has been pushed in the Arduino UNO and we can see the results on the motor. You can see that the motor is not moving, it's static on its position, which is to be expected with 90 degrees. Now how about if we change this from 90 to, let's just say, 76 degrees. So my servo.write 76 and will once again build this code and upload this code to Arduino UNO, and let's see the results this time. So the code has been pushed successfully. I'll click reset on Arduino UNO and let's see the results. You can see that the motor is moving in the clockwise direction with a specific speed. Now this time let's change this from 76 to maybe 34 degrees, right? Once again I'll build the code and flash the code. You can see this time the motor is moving in the clockwise direction but with more speed than last time. And lastly, let's write 2 over here, so it's almost the maximum speed in clockwise direction. I'll build this once again and push this and let's see the results. And once again you can see this time it's much faster than before. Alright, now let's move on to counterclockwise direction. I'll write here, let's just say 123. I'll build this code, push this and let's see the results. You can see now the servo motor is moving in counterclockwise direction and with a slightly slow speed. Let's try full 180 this time and see the results. You can see now it's moving in the counterclockwise direction but much faster than last time. Now I also want to show you at this point that this part right here where the motor is supposed to stall or stop is not exactly one specific point like 90 degrees. So for demo let's write 93 degrees or 88 degree to our servo. So I'll open up VS Code and let's write here maybe 93 degrees and let's see the results. You can see that the code has been uploaded successfully with 93 degrees and the shaft of the motor is static, it's not moving. Now I also want to show you a demo of this code right here. You can see they're also using the 9 number pin, which is convenient for us. It's a for loop which goes from 0 to 180 degrees. So 0 is maximum speed in one direction, so it will start with maximum speed in one direction, then it will keep increasing the degrees up till 88 or 90 degrees where it's supposed to stop, and then as the values increase from there it will start rotating in the other direction, first slowly and then up till 180 where it will be at maximum speed in the other direction, and then it will reverse the behavior, it will go from 180 to 0. So it's supposed to go from maximum speed in one direction to static 0 and then maximum speed in other direction, and it will loop through this. So let's push this code. I'll just copy this code from here. I will paste this in my VS Code over here, and it's showing some error. Delay is undefined. We need to also include the Arduino library here, Arduino.h. Okay, with that the error is gone. We will build this code, and once it's built successfully we will flash this to the microcontroller. You can see the behavior of the servo motor. It's going in both directions and stopping in between, just as we expected from this code. Now at this point there are other methods which you can use with my servo library as well. These are the different methods, and you can go inside each one of those and see different ways to interact with the servo motor. But for this tutorial this will be it. If you have any questions or want me to work on some other tutorial for you, feel free to let me know in the comment section below. Till then, see you in the next video. Bye bye.